Hello all. Okay, in this video I'm going to be taking apart an old keyboard, a musical keyboard. Now I've had it in storage for years, it doesn't work, it's destined for the skip, so I'm just going to take it to pieces, see what's inside and share the footage with you, those that are like-minded like myself, because I want to see inside this keyboard. So I'll show you what it is first of all. So this is the keyboard I'm going to be to take apart. It's a Yamaha, a PC 1000. It's beyond repair, it's destined for the skip. So I'm going to just take it to pieces, see what's inside it. And you'll know, as I say, that I do this sort of stuff out the back is out the house, so it doesn't make a mess of the house, and I don't get in the way. But it's going to get disassembled first, before it goes to the skip. And this is the other side of it. Turn it right side up again, I'll show you the... It's just the back where the connectors go. So that's what the keyboard looks like. Now, I'm not a musician, so I don't know all the things about all the music stuff and all that. I'm not in hopeless with music. But the keyboard that I use for my videos, for my background music, it's an old one from the 80s I got from my cousin. And that's a good one. It's a Casio, and that will be getting kept and used, and I'll be looking after that one. So that won't be getting disassembled. This one, as I say, on the other hand, is just it's finished. So I'm going to break this one up. Right, first thing I'll do is reveal how to get into it. I've turned it upside down. There's a Phillips screw down there. There's some missing. It's been in storage for a considerable length of time, so I can only see one at the moment. There's meant to be, I think there's meant to be more going round the outside edge, but there's one there. I should say, I'll rephrase that, there's one left. So, on the other side, let's see what's on this bit. Right, doesn't seem to be any fixings. See, it's already sort of like coming apart, so it shouldn't be that difficult to get in. So I'll take the screw out. Phillips, just one Phillips screw. There's meant to be more going round. For some reason, a lot of them are missing. I can't remember why or how that is, but I'm going to remove that one anyway. So I'm filming with my left hand and right-handed, so I'll use my right hand to remove the screw. It's not magnetic, unfortunately. Fair length, got a deep screw that's come out of that. So that should then reveal the bottom of it. Right, so I've removed the back, the bottom rather. So with the bottom removed, this tube here will be, well, the batteries will go in there at this side for operating it portable. So that goes on there. That's where they go in, and then it just connects up. Picture of this. So all the screws that were missing are stuck to the speaker here because that means the screws were actually magnetic and ferrous. Well, not magnetic, but they were ferrous metals, had iron in them, so therefore attracted to magnets. And they were all sticking to the speaker cone magnet when I took the cover off. So that, presumably this had been opened before, well, almost certainly would have been opened before, and all these screws have somehow just been, as it's been in storage, and they've maybe just rolled and I got caught with this magnet. I mean, it'd been opened before, maybe because it was knackered to see it. So I'll just get rid of them. So the connector bit at the back, in fact this circuit board isn't even held in. So all I've done is I think this has been taken apart before. I looked at or checked or something, but I can't remember just what's been done to it. It's been stored away for years, and it's obviously been tinkered around with. Whether I done it or someone else done it, I can't remember, but anyhow, it's definitely been opened up before. So this is the lot of microprocessors and that. Well, microchips rather. I think this is built at the time where it was more like just microchips rather than like these super deluxe microprocessors you get in your mobile phones and PCs nowadays. This is like 80s stuff, technology. It's still a silicon chip, but there's quite a few of them. I think if this was a modern keyboard of today, it'd probably have like these super deluxe microprocessors that, you know, you could about this size, that could probably do the job of this whole entire board, you know. But that's just my impression anyway. I don't know, I'm not an electrician, so I couldn't tell you exactly about the specifications of it or anything, but I know that they are microchips, silicon chips, but there's no as many legs on them. Like if you see inside a mobile or a PC these days, it's tiny and it's got micro legs, well, loads of them all the way around it. But this is like a step, this is like the predecessors to today's standards, you know. Things get smaller and smaller and more complicated. So this is the back end of the bottom of the keys. What I'm going to do is actually just going to remove I'm going to unplug this board. I'll start by pulling these connectors off to separate the board. So I think it's been pretty well built. It's got loads of insulation, this sort of foam stuff on the wires. Now I'm doing this one-handed with my left hand, and I'll just put this down a minute. I might as well keep doing it. I'm going to stop filming for a minute. So it's just a case of pulling it apart. I've pulled the connector blocks, these connectors off, and the circuit board has just came out just like that, basically. And in the back you've got your chart and power input. That's the power input chart there, I think. No, it's not, it's headphones for the power input. Might be it. See how it corresponds with the. Great. Oh, there we go. Yeah, far left. So it's going to be a one of these ends. So it'll be that one there then. Yeah, that's for the power in. These are your other things that correspond with them. That's the power in one there, which is that. Okay, so I've done that. Next thing I'm going to do is remove this bit here. Now this is where the batteries, the other side of the batteries. I don't know why there's this tube here, unless actually, come to think of it, it might take quite a few batteries. Yeah, that's what it'll be. That'll be the big 1.5 times 6. That's the reason why it's so deep. 6 batteries go in there and they'll slide down. They'll slide down there. They'll connect up positive to negative in series to give the desired voltage to work. So that's where that is, battery tube. I'll take it apart. Small Phillips screwdriver required for this task. You get the idea. I just got a smaller one. Right, big spring where the negative part of the battery goes to. So they all slide down. It's kind of like a felt material. It's adhesived on. That'll be the negative side wire that goes into the connector block, which will the power board. That's the positive side. for the batteries, so that's that bit removed. I'm just going to break this wire off here. That was soldered on, just so I could get the black out of the way. I'm not quite sure what this is though. This black wire. Oh, there's this thing that's stuck here. There's something under it. Oh no, I've just broken it. I'm going to have to rip this off. I want to know what that is. To reveal what's behind there, I've got a flat screwdriver and I'm just going to pry my way in, push my way in to see if there's any clues to what that was. But you get the idea what I'm doing. Okay, so on closer inspection, it seems to be like perhaps like an anti-static thing or something to prevent interference maybe. It's got a silver line, not black, but it's just the connector for the, it's a bit of adhesive tape, that's where that black wire connects to. Now I'm not sure where it connected to at the other end. It might be an anti-static thing because there is a silver like line in there. And when there's delicate instruments, because this is sort of corresponding side to it, it's to stop any interference affecting the electronics like any other electrical signals from within here or from external sources around the house, for example. Radio waves, perhaps. I mean, I'm not sure, but that's my guess. I don't know what that is. That's maybe just some sort of locking thing. Oh, 1 minute now. Stand, that's for the stand up. This keyboard had a stand mount originally. Just to make one thing clear as well on this video is only for entertainment purposes, so don't quote me on any of the stuff that I'm mentioning as fact, because I'm not an electrician or a keyboard electronic repair guy. And I mean, you probably need to go to university and do it. I don't have that. My dad is an electrician, but this is, I'm not disturbing my dad for this video. This is my idea. He's doing his things, I'm doing my thing, my video, and I just give you my understanding of what these parts do inside there. So don't take this as a quote that that's what it is. It's only my guess and what I reckon that the things are that are going on in there, or what went on in there when it was working. But the video is only solely just for entertainment purposes, to show you what's inside it and give you my understanding of what I reckon these things are. So don't say, oh, that's what it is, you know, and quote me on it. Don't, because I'm not like the qualified, these PC guys that will know all the spiel and all the bump that goes on in there, all the engine, all the technical stuff. You need to go to university to get the full, full understanding of it before you can start quoting it on YouTube to say that this is how it works. This is only saying this is what I think. So your viewers might be able to correct me if I'm wrong, but I'm just thinking that that's what that silver bit was for. From what other things that I've done before, that silver shielding to stop any other electrical interference, because sensitive electronics could get upset easily with interference, so they put this there to reflect the waves, interference waves, away from it. Now this is on the opposite side where that was. There's also like I think because it's a keyboard and it's acoustics, all this stuff here wrapped on these wires is to prevent any resonance, any resonant frequencies, any vibrations or stuff, because there is a built-in speaker, and it's, when you're doing music, you don't want any things loose inside this keyboard, because it will vibrate and it will affect the sound produced that you're trying to make. So if you're doing a piece of music, you don't want anything vibrating inside the keyboard that will affect the overall sound. So all this stuff here is all padded to perhaps dampen anything going on, because this speaker will vibrate things. That's how a speaker works. It vibrates the air molecules, vibrates the air, and that's how you hear it. It vibrates your eardrum. But in turn, because it's connected directly to all this, these wires and stuff are all coated with this foam to maybe keep it from setting up a vibration. That's my guess. Now, whatever this silver thing is, it's quite sticky. So I could only think it's either not an earthing, but these resistors, I'll be anti-interference, but these resistors there, I think they're resistors, or are they resistors? I'm guessing they are, but that'll be in relation to the keys. So when you hit the keyboard, you're actually touching, you're using the buttons. Now I'm moving this, can't see anything right now. I'll have to break into more to find out, but I'm going to do actually is I'm going to disconnect these plugs and get this whole circuit board off to reveal what's behind the keys. Now to do that, screws. So there's just pull off connectors and connect on, and then I think that'll be the main mounting screws. That and that. Maybe them as well. So what I'm going to do is now take these Phillips screws off, see if I can remove this to reveal what's behind the keys. So Phillips screwdriver, slacking them anti-clockwise. So I'm going to stop recording in a moment so I can just basically crack on with this bit. Okay, so this is the size of screws that have come out. So I'll put all the screws in there just now. Okay, so I've took the screws out from this circuit board. It's at the bottom of the keys. And I think, again, this foam stuff here is to prevent any resistance, any vibrations and that. Now, these will be resistors, so I think when you hit the keyboard, it will produce a note depending on the resistance. No, we're seeing stuff happening. So if I hit one of the black keys, you see it moving. So just basically, you can see what I'm doing. You press the keys, and at the other side of it, you've got these pegs which will press onto something on the circuit board. Now, does it press onto those? This is where I'm gonna have to see how it lines up. So let's try and find its original position again. So there's these little indentations there. Now where do they correspond now? Yeah, right, so these pegs, when you're hitting the keys and you're playing the music, the pegs, you can see the evident marks on there. They press against this, which in turn press against these, which will complete a circuit perhaps. I think that might be the insulating bit there. I'm not 100% sure what's happening here, but it certainly seems to me anyway that when you're pressing the keys, that will push against this sort of like rubber-like material, which will cause something to happen that may break the circuit or create a circuit. It must make contact with this, because they're all in line with the keys by the look of it. And at the other side of this, there's a corresponding resistor. So these resistors will be calibrated to the note. That will determine the note. I think they're resistors anyway. So depending on the value, maybe it will depend on the pitch of the note. That'll set a signal for each key that it's been pressed. So that'll then go to the circuit board. Now these also double up for other things as well, because you can set your tempo, the rhythm, using these keys. So these keys will probably have their own signature signal, so that'll be, each of them will be individually producing perhaps its own individual signal, and then when that key's pressed, the circuit board will recognise that key's pressed. And depending on what setting you've got, because you could adjust other things on here as well, you can adjust all this stuff. You know, so these keys will not only act as, like, for example, a piano, it could do other things. But the signal, the actual key will be recognised, you know, of its own unique resistance value, perhaps. So when that key's pressed, it will set up, it will be specific calibration, there'll be a specific setting for that key. Depending on what set you've got on here, that key could double up to do other things as well, you see. But the key will have its own address, or its own signature. That signature could also be used to do other things as well, depending on what settings been selected on the you know, the control at the top here. So you could adjust the rhythm, you could, you know, do a lot of other things. So it's multifunctional, these keys. But the actual keynote itself will have its own unique signature, probably based on the value of the resistors maybe. And then depending on the setting, this motherboard the main circuit board will determine what sort of sounds to come out. So let's just say you press key 1. Key 1 on setting rhythm, that will go to the rhythm setting for key 1. And if you go for the piano, key 1 for piano, it will go to the piano setting. And if you go maybe key 1 for the organ, it will have key 1 signal coming in, and then it will go to the corresponding organ setting for that. That's my guess. Like I said before, I'm not a keyboard expert, but I'm just sort of giving you my understanding of it. And as I say, there's a lot of this stuff here, foam, as a preventative for any vibration setup. Because as I say, the speaker is right here, and that produces a lot of vibration because that's how a speaker works. It vibrates air molecules, which, if things are slack in here, it will resonate, it will interfere with the sound of your overall music. You don't want that. So with that aside, the keyboard circuit aside, I'm going to then now going deeper. I'm going to remove these Phillips screws and I'm going to get into the actual pegs, the keynotes. I'm going to see what's under here. So once again, that would be a Phillips screwdriver, and you get the idea. So I've just got that one, that one, that one, that one, and I think there's a couple there as well. So I'm going to put the phone down and crack on with that. Little black cable here was screwed in with a serrated washer. I'm going to guess because this is metal, it's there to maybe reduce static discharge, something on the lines of this as well, you know, to prevent static, which is interference or something, a grounding strap or something. I'm just guessing, because this is made out of actual metal, so that was there maybe to take away any, I don't know, static or any, to discharge anything, prevent any interference, because right next to it you've got that circuit board with the delicate sensors on them. I'll sense what key you pressed. So anyway, I'm going to continue on and move these screws to get this metal key retainer, which will be holding all the keys in. And there's this one wee screw, it's tucked in right at the back there that I just about overlooked. There's another screw tucked in at the back that is hiding away from me, that needs to come up. Well, the screw's out, it's slack, but it's not coming out, it's still retained in. But this looks like to be the whole button assembly. It's quite sturdy, it's still held in somehow. It's maybe needing to be unclipped from somewhere, but for that I might have to put the phone down. Take it out. Oh no, here we go. Just yanked it a little bit. I'll have to put the phone down in a minute. Yeah, so it comes out. It was just kind of like unhooking it, the whole button assembly from the rest of the keyboard, basically the plastic keyboard housing. But the actual button panel, which is quite interesting, it's quite cool. This is basically going to have to be well precisely put together, because that's going to be doing all the the amount of times you press them, it's going to be well made. Ones are going to be keyed, spaced apart, all level, so quality will be good to see what's going on, I hope. So I don't know if there's any, I don't know if the pegs do anything. I think that's maybe just the button stop, so it goes as far. There must be a spring in there, spring back. Now, in order to find it out, I'd have to break one of the buttons off to see what's behind it. Unless there's a way in. There must be some sort of spring in there to put the button back into its original position. Let's just look into that later. What we'll do now is these circuit boards, that's for your settings. So you've got there's a digital display as well in here. This particular model has it's a liquid crystal display. So all these settings will have pegs at the at the backs of the buttons that will work on the similar principle to the keys that will just press the actual buttons on the circuit board. So I'm going to remove these circuit boards anyway, these circuit boards is what's responsible for all your settings. So I'm going to remove all of them now. And to do that, I will require a Phillips screwdriver. Slacking them off. So I'm going to just put the camera down for now, and I'm just going to crack on getting all that off because there's quite a lot to get into. This is an 80s keyboard. Like I said before, the modern ones will probably have a microprocessor that will basically have all the tasks this will do will be compressed into a wee chip about this size, about a wee square chip about an inch in square perhaps. But this is built in the 80s, so there's a lot more microchips to make this work. Whereas modern stuff, they could the modern microprocessor nowadays could probably do the same task as this whole, all the thinking part of the board. So it makes everything smaller. Because that black keyboard I've got, the Casio one I got in the 90s, is smaller than this. It does more. Well, it does quite a bit anyway. I think the 80s one I got from my cousin's quite an old one, and it's pretty big, good quality. But the black one isn't quite as good quality, but it's got more variety, but the quality is not as good. And they're shrinking it in size because of the microprocessors. Anyway, let's just get the circuit board out. We'll just put this down for now. Just that being an 80s product, there's more to take apart, there's more stuff to get into because it requires a lot more. The modern stuff, it's all shrunk down into microprocessors, which makes the whole thing small. So that's why I need to get on with this, because there's quite a bit to go yet. If this was a modern one, it'd probably just be one circuit board and that'd be it all. So it took quite considerable time to get that off. There was lots of screws to remove to get that off. Now that's plugged into the speaker. No, that's plugged into actually the speaker, is it? The headphones. So is it popping? Plug, pull out. Unplugged. Then you've got the speaker spade connectors that need to be pulled off there. So try and do. I'll put this camera down for that. Oh no, I can't actually do it with my left hand. I'm right-handed, but might as well be left-handed with it. Actually, no, I'll just put it down. To remove this, so there's another connector that needs to come off. You can see just how much, that's the buttons actually just showing right through. So the buttons are actually directly just fixed to the circuit board through the casing. That'll be what's that now? Show what this bit is here. just unscrew it anyway. So far it's all been Phillips screws. It's one thing, it's one screwdriver, maybe two Phillips. What's required to get this completely disassembled. Well, this would probably be done in the bottom covers as well. Now I think I've managed to get this whole entire assembly off. Now that's everything. Display LED lights, your buttons, your sliders, they all correspond with the volume. I'll tell you actually one of the things here. So that all matches up with the, I mean there's a lot to go in these things. I mean the 80 stuff was built, a lot more craftsmanship went into them. I think as I say the modern stuff it would all be compressed into a lot less. You know, one circuit board does all kind of thing because of the microprocessors on them. But you could kind of like see that that matches with that. That matches your main volume set there. There's a display there on the back. Liquid crystal display, that'll be at the end. Put Phillips onto that one and get that removed so we could get a closer look at that. So it's just Phillips screws at the plastic, it's not been any problems getting them off, it's really quite easy. That's a liquid crystal display. Now we've got these other like circuit boards as well, then you've got the speaker, but what are they for now? So there's little display lights there going along this edge. I'm guessing that that's what these circuit boards will be for. Now it's a very fine flat screwdriver, I don't know if this one will work actually. It does work, which is good. I do have to go into the toolbox and go and hit them all. But it's quite a sharp screwdriver this one, and they are in fact metallic. Well, the screwdriver's metallic and the screws are ferrous. Which means you can get them out. They come out nice and easy. So I've got a few to do. Again, there's no point in filming all this because you probably get the idea what I'm doing. Saying that, I've got this far, I might as well just keep the camera rolling. It's not tight, it's just fine screws holding the Formica circuit board or printed circuit board onto plastic. So there isn't any torque in these screws, are nice and easy to slacken, and it should just all lift out, which it does nice and easily. Perfect. And there's the displays at the back, that'll be probably LEDs, light emitting diodes, that will correspond with these lenses, or not even lenses, they just literally go right through. So they're just, that's just nothing there now, it's just all this is the holes. It's a little lens for the display, that's just to protect it. Might enlarge the magnifier a bit, I don't know. But yeah, all this stuff just goes right through the plastic. The plastic is just literally allowing the buttons to go through. That's not the order then, but you get the idea. You just simply push through there. There's no mechanical stuff or anything on here. Well, I should tell you that's probably the only mechanical thing is your main stop. The buttons have just fallen out. So they just are housed in there. Again, that will be corresponding to, that's the bit you press, that's the bit at the back that corresponds to something on the circuit board there. Now one thing left is the speaker and the microphone, the headphone board. So I'm going to remove the speaker. To do that, I'm looking too easy because I can't find any means to get this out unless it's just pegged on. So you press these pegs back and the whole bit at the front should come off. I'd assume this whole thing would, put the camera in a minute. Yeah, so basically that's the speaker cover. So that was just being unclipped. That's the bit that goes on the front. So I'll have to show you what's going on here. The speaker's held in with 4 Phillips screws at each corner. That bit there was just a push fit. That's to protect the speaker. And it's held in with the little pegs there. So basically just unpried, push back on them, unhook them from, there's 4 of them at each corner. Each side, 2 each side. And that allows for this to come off. So that's the little pegs that you just pushed back on very slightly, just unhook it from there. So this lifts off and that reveals the speaker, which is mouldy. And it's held in with 4, is that dust? Sure, either dust or mould. It wouldn't surprise me if it was mould. It's been stored away for years, so probably is mould. But there's 4, again, nice and easy to remove, Phillips screws. I'm not had any bother getting this thing taken apart. You see, there's not so much moulding, it's all handcrafted. That's how things are built nowadays. Whereas modern stuff, they tend to use moulding and everything's all moulded together, sealed for life kind of thing, throwaway society. So when it breaks, you chuck it out, you get another one. Whereas in the earlier days, like this, you could open it up, actually repair things, replace things. That's my understanding of it. Anyway, that's the speaker. This is what produces all the sounds that you'll hear from this keyboard. Peppercorn speaker. And a big speaker magnet on the back there. And the wattage, it's for 5 watts. 4 ohms and 5 watts. I'd have thought it'd have been more than that, but so it's reading it in the back. So I think this plastic dress strip, this is really it. What's this now? They're grommets. That's for the sliders. So they would pretty much correspond with the sliders on the circuit board. That's just the dust shield, dust cover, just to stop dirt and that from going in to the circuit board. So they have these, I'm guessing that's what these rubber, and again it's also to seal everything up. Everything wants to be tight. There's no any room for movement or any vibrations. If any vibrations are happening, then the rubber at any joins will absorb some of it, so it keeps all the vibrations down to a minimum. Because you don't want to hear any vibrations when you're playing music, because it's a musical acoustic device, so you don't want any noise from anything vibrating around that's slack, because it will just interfere with it. This thing is designed solely for music and sound and acoustics, so they put effort in there to eliminate anything that will interfere with that acoustically. Now, the jack plug for the headphones, there's like this is the first time I've actually had to use something different. To slacken that is like I'd have to get this ring to go anti-clockwise. You could probably get pliers or maybe just get a flat screwdriver in there and just try and take that off. So I'm going to do that. I won't be able to film that because I'm going to need both hands to do that. So I've managed to slacken that and off it comes. So the lock ring here, I've got pliers on them and just, I don't have the right tools, I just improvised with them and just persevered, got it off. It was only, it was the hardest bit that gave us resistance, but that just screws on that thread there. That's your jack plug for the headphone socket, which is removed from the plastic, and that's it. That's just completely down, stripped out, completely stripped down, nothing left. It's just a bit of plastic. Now there was numbers I noticed on the back of this keyboard, the key assembly. No, there was. There we go. Let me just see them. Maybe not, the camera's maybe not picking them up. Yeah, maybe 90, 92. So I don't know if it's coming out in the camera or no, but there's numbers on these in the white notes, white keys. But this, I don't think there's any electrical stuff in here. Not quite sure what will happen. I think if I take these off, all the keys will go everywhere. And yeah, I do want to see that, although I don't know if that's going to happen actually. Not quite sure. Now you get the keys out then. How do the keys come out? I don't know if there's a spring under there. I'm going to remove the Phillips screws. I don't think that's what's going to hold everything together. I think that's just a bracket. That's just to hold the bracket on. So this whole assembly is fixed to the keyboard. So this is a bracket. That 2 screws hold this bracket on, and there's another screw that goes through there that holds the assembly. But to get into the keys, I don't know. I don't really want to just break it, but well, I've done it already. So there is a spring that just kind of like moved. I don't know if you saw that. It's rolled away, rolled inside. Enough. I've broken that there, this spring there, look. So I was right, there was a spring, that's a retaining spring that basically just pushes the keys back up to the upright position. So when you press down on them, you're positioning the spring. Maybe give up one of the black ones out as well, see. Say a proper method of getting them out without actually just yanking them out. And they do in fact unflip. Well, that black one did anyway, it was off camera. I don't think I could replicate that again, but it did just unclip anyway. You could see that clips in over there. I'll put the camera down, I'll see if we can remove a couple more without actually wrecking it. Without wrecking it any more than I've already wrecked it. I'll rephrase that. Yeah, so what it is, you push down on there, at the same time you just unhook it. So there is a proper way of doing it. And you can see how it's kind of like hooked in there. So I'm pressing down there, pulling up at the same time. I should be doing the black one next. So it is difficult to fill them in at the same time and do this. I really need to have both hands. But what I'm trying to do is push down on there, right, which kind of releases the key from the back, and then at the same time I'm pulling it up. So it comes out from the top there. No, I can't really, well, this was sticking, so I'll put the phone. So I've yanked a few more out properly, and you can see how the spring's actually, how it's located. And then, you see, that's what pushes the keys back into its original position. I hope you can see what's going on anyway. And that's the peg that makes contact with the socket board here. It causes something to happen, but these are all linked up to the keys that are on here, this keyboard assembly, this key assembly. But there's loads of bits and pieces inside this, lots of wee bits. It's a lot more than I thought, to be honest. It's taking longer than I thought. There is tons of things in here. I didn't expect to be finding more and more. But then the later videos I've done were molding things. So the molding things tend to eliminate a lot of stuff. And the processes that which they're built are also a lot more plastic moulding. This would probably have to be done in the factory individually, and whereas molding things are all done in moulding and casting and whatnot. I think molding stuff on the break they just replace them. In fact, that's what they tend to do. But there's an old thing you would have to actually spend time repairing them because they do come apart. They're hand assembled and they would be reassembled by hand. Whereas modern things, I think they're kind of all plastic moulded and sealed for life stuff. Boring, you know, you don't really get much excitement to seeing it. In general, when it comes to electronic things, I don't know about modern stuff, but the electronic stuff that I've done took apart the modern things. All this is eliminated with a compressor and a wee microprocessor. It doesn't even look that exciting. But anyway, I think you get the idea, I hope, what's going on here. So seriously, keys missing on this. So you can see the springs, the locators, This is a pretty sturdy bit of metal, because this has got to be firm to keep these keys, because this is going to be used a lot. Things you press them, so everything's got to be pretty sturdily put together. So this bit is actually metal. I somehow think if this was emulsion, that would be some plastic composite stuff that, you know, lightness and easy to manufacture, cheap to manufacture, but still dear to buy, like. But now what's there on the bottom? These are for the mounting, for the stand, the keyboard stand. So you're sitting in a chair, the keyboard's actually going to be resting on legs to be at your height. That's removed, I don't have that. The stand, there's not really much to see, it's just two bits of metal, polished chrome metal in a sort of X shaped. And all it does is support the keyboard at height. You probably adjust it, but not much to see. But that's what they were. Stand. That's corresponding. So what else is there? That's like rubber feet. Again, being a keyboard, it's going to be sit levelled rubber just so it doesn't scratch surfaces. It keeps everything sort of tight, vibration free. Again, there's some felt around there as well, just to absorb any vibrations in the plastic case. Because vibrations in a keyboard you don't want, because it will interfere with the sound. It's the acoustic thing, it's all about sound. So all you want to hear is the sound coming out that speaker. So everything else, no vibrations are allowed. So the vibrations will not be tolerated. So to eliminate, so it's high tolerance. They don't tolerate. I should say low tolerance, isn't it? They won't tolerate vibrations, so they spend a lot of time and effort adding felt and foam and putting them under the wires to bring that tolerance, a tighter tolerance for it. So there's no vibrations. They want to try and get rid of all vibrations. So even this has got, all the edges have got felt going right around it, because the felt will absorb any sound. Anyway, headphone socket. It's just a bundle now, isn't it? I think that was just a keyboard. Right, so what I'm going to do now, at least that's what I'm going to try and do now, is I'm going to try and get that into some sort of orderly fashion, so I could summarise and get some full shots of the individual components that went into this keyboard. So as such, I'm going to get like circuit boards there, wiring harnesses there, speakers, casing there, that sort of thing. I'll try and get this into some sort of ordinary fashion so you could compartmentise, have summarise sections like casing section, keyboard section, speaker section, circuit board section, etc. So I'm going to be to try and do my best with that now. Right, so I've sort of like got them in some kind of order. I shall try and summarise. Right, okay, so this is all the bits and pieces. There's like a wee handful of screws down there in that corner for holding the casing together. Starting with this, there's a whole multitude of fixtures, screws for a whole range of things, holding circuit boards into miscellaneous parts. So that's this little bundle of stuff here. This printed circuit board, that's tasked. The task of this is for being a wee light display above the keys. So these are all lit up, and this is the circuit board, and this is the lights that cause that to happen. Right, so that's what that does. Next, this here is the circuit boards and switch gear and sliders, etc. It's responsible for your controls, for your keyboard, for your settings. There they are there, right? So that circuit board just goes through this casing. The casing has all been shaped. There's all the switch gear and everything. The spaces are all on this, and all that does is the circuit boards slide up, as I showed earlier. The buttons come through like that. So this is just demonstrating. Right, they actually come through, they protrude through. The buttons are directly fixed to the circuit board, as you could see. And there's also some LED lights as well, red ones, that will light up correspondingly. So the corresponding LED light holes on this plastic mould casing, these will just push through from the bottom and they'll protrude up into there. That's your main power on and off button. So it's your on and off. That's simple. That just slides through. There's probably a wee knob or something, or a wee sort of plastic bit goes on the top. You know, it's missing at the moment. It probably came off when I'll be on that lot somewhere, but it just basically push fits on, and that's your finishing touch. Your plastic bits what you actually make contact with. So you didn't want it like that, so they put a wee plastic bit on the top. That's somewhere amongst this, maybe somewhere on the ground or something, I don't know. I'll find it later. But anyway, next you have this circuit board, and that is what's responsible for the key, the keys, the actual keys. That's responsible for taking the commands from this. So when you hit the key, right, the pegs in the back, right, you can see them moving when I move them, right, the pegs are going to hit or make contact with this, I think, which will, so each key's got its own set value, and these values will be determined by these wee resistors, I'm guessing. That's how it works. I haven't even bothered to count them all, and to be quite frank, I can't be arsed, so I'm just going to take a wild guess. All these resistors are going to be corresponding to, there'll be a set value. Each key will have its own value, so when you hit the keys, or a key, so you hit this key, right, that peg's moving, right, that's going to press against something on here, right, with the preset value, which will send a signal with that preset value to this circuit board, which is the main brain, the motherboard circuit board, right, we'll just call it the motherboard circuit board. It'll be relayed through wires, because you have connector blocks with wires, so a wiring harness. So when you hit that button, that value signal will be sent through the wires to the corresponding plug on this motherboard. This will do all the thinking. It'll deter whether what setting you've got it set for, whether it's, say you've got it set on any of them, right, so it knows what you've got it set because you've selected the settings in that, so that will deter what the value of that key will do in relation to your setting. That will be done through this motherboard. All these microchips will do all the thinking. Microprocessors, semiconductors will work using binary logic to deter what that value will do. There must be a sound board, that'll be the amplifier, I presume, because it's got a heat sink on it. That's a heat sink. It's a transistor amplifier. Amplifies. Can't get the wattage value on it, but that's the amplifier, I presume, which will then make a wee signal, amplify it into a big signal. There's another amplifier there, or a heat sink anyway, but that big signal will be strong enough once it's been amplified to be reproduced by the speaker, because that signal for the amplifier, right, has got to, once it's amplified, it's got to have 5 watts of power to move this paper cone to the frequency that's being produced by the value, the set value by each note of the key that you press. So it'll go in as a weak signal, goes through all this processing stuff, then it gets amplified. This will get warm or hot, this heat sink, because it's dealing with power. So it's like switching off and on in a wee signal to switch this transistor semiconductor off and on with the big signal, which will be driving the speaker. There's a coil of wire in there with the magnet, uses electromagnetic principle, which is mechanical, so as it powers up, the cone will either expand or collapse due to whether there's current on or not. The current will be determined by the signal. You might just see the coil in there. If I could zoom this in, try my best. In there. So anyhow, when this speaker vibrates at a frequency so many times a second, in hertz is measured in, hundreds, thousands of times a second, that will vibrate the air molecules, which will produce the note that you'll hear by your eardrum, and it'll be picked up as sound. So basically the sound out of that will be, ultimately when you hit a key on there, it'll end up as sound coming out of this speaker, which you'll hear, and it will be deterred on what value of key that you hit with these resistors on here. So that's your settings board, and just some LED lights on there as well that will match up keyboard board. So I probably would have gathered by now that this is the main brain, this is the main deal. We've got jack plugs in at the back, there's a wee adjuster thing here as well that will adjust the pitch of the whole thing. So if you mess around with that, you could end up upsetting the whole tone of the keyboard. So you got to, I think this sets the whole keyboard up, the tone of everything. So that'll, if you adjust this, I think anyway, if you adjust that, it could, you know, upset everything, because everything's got its value. But that, I think that's the overall, like the final drive, like a final value. I'm not sure. I'm not a musician, so I don't know. I'm not a music person, so I don't really know it, but it's certainly a variable potentiometer. So when you turn that, it's like increasing or decreasing resistance in this thing there you might see moving, and that'll change the values of it, which will be picked up in with this. So that'll ken what to do next. Basically, it'll sort something out and it'll adjust the desired value that you do. Next, keys. So your white keys, your black keys, you've got springs that sit in the hooks in these cups. Whatever. The keys are hooked onto the main key assembly unit, which is made out of metal, which is quite sturdy. It's probably the heaviest part actually. It is quite sturdy, so you can hear it's metal. So their keys are hooked on, as I showed you earlier in the video. They sort of hook on at the back and hook on there, and that's the peg that makes contact with the board. This board here, with the values, preset value for each key, I'm guessing. Anyway, that's all it is. This will be like the key guides. You know, it's got to keep the keys in line, and it's just sort of part of the assembly basically. There's nothing electrical in there. Like you can see, there's not any electrical stuff, it's just mechanical movement that moves that peg. That's ultimately all this assembly is. It's quite sturdy because this is the bit that's going to be getting in contact with when you're using the keyboard. So it's going to be doing a lot of the mechanical stuff. When you move and press these, this has got to stay firm, because you don't want to warping about and causing all sorts of problems. But through wear and tear, it's built to last, so it's made out of steel, or galvanised steel or something. But that's your keyboard, your key assembly anyway. And there's the corresponding keys that, as I say, fit in, and these springs just put the keys back to the upright position. Right, next you've got the battery channel. So you've got the option to plug it into the wall and put a power supply in, which is what I would prefer personally. I don't like batteries, they just go flat. But you can, portably, you can take this keyboard out, you can take it out the house and play it outside if you want, because it's got its own power supply built in, VA6 1.5 volt batteries, I think they are. Let's see what it says again. Yeah, so 1.5 volt batteries, 6 of them. That's the big cylinder type batteries. The big, you know, the big chunky batteries, like you can see how big the tubing is in there. So they're quite big batteries. The batteries slide down the channel. They go in from the bit of the battery there, goes in there, slide down, the negative bit goes, the back of the battery goes in there. They're all in series, and this is just the corresponding tube that they sit in. You would have seen me take that apart. And the negative wire's got its connector. Now there's 2 wires on there, actually. 2 of them. But the positive side for the battery is there. So the positive go. So that's 9 volts in total, basically. So that's that, and that's just the flap that goes on the bottom for the batteries. Again, it's got this insulation stuff in it just to absorb any vibrations caused due to the speaker being mounted in the same. You know, I think if it was really expensive keyboards, I'm guessing that the speakers would be a separate item altogether. It'd probably be a very powerful amplifier, and the keyboard will be a keyboard, then it'll probably go into an amp, auxiliary amp, then it'll go into separate speakers. But this is all bolted as one unit. So the speaker is all connected, it's inside this, which means this is making a lot of sound. All that sound is going to cause vibration if things aren't tightened up and all padded up, like, you know, wires are free to move, and when they do, they may cause vibrations. So they coat the wires, so just basically put this foam around the wires, so when if there's any movement, the foam will absorb the vibrations. That's my guess, and that's my reckoning of it anyway. So next, casing. Probably speaks for itself. It's the main plastic dress strip, the whole thing. There's nothing else electrical on here. It's just plastic mould, and you've got the top, it's the main one, and then you've got the bottom, which is holds it together. That's just feet, plastic feet. That's just little rubber bits on the feet when this keyboard's sitting on a table. It doesn't score the table, and it keeps it level as well, and just so that it doesn't set vibrations up through the table that it's on. It's got the rubber molded feet, rubbers on the bottoms of the feet. There's a felt trim that goes all the way around the edge. That's where the top half of the case meets the bottom, so it goes like, basically it goes like that. So as I say, that felt there is just to stop any vibrations, absorb any vibrations produced by the speaker. And it's quite a considerable bit lighter now as well with everything out of it. That's all the guts out of it. This is just the speaker dress that goes over the protect the speaker that sits on like such on there. And these, as I mentioned, there's this clip. I mean, I could put them back in. Doesn't really matter because the speaker's removed. I had to remove that to get the 4 Phillips screws that hold the speaker in. I think it was them. I can't really think of anything else, to be honest. Oh yeah, this digital display. So that was situated here. Well, actually it would have been under, like, something like that anyway, right? Let's see. Come on, like, there you go, like, you get the idea. It goes in like, there we go. So, digital display is just, it's fitted in for the back. You saw me take it apart anyway, so you look back, you'll see it. And that'll be the actual liquid crystal display. No, I just spotted a microprocessor. A small one at that, but that is more modern like. See, like nowadays, right, you go into electronic devices nowadays, you know, household stuff, DVDs, TVs, stuff like that, right? I mean, the washing machines, for example, I've done recently in my washing machine series, they've got microprocessors in it. This is what they look like. Now, this is probably the most intricate part, integrated circuit board. This is probably the smallest I've seen so far. This is the step towards what most of the modern stuff is like nowadays. That's what I was on about earlier, right? You compare it, right? This is your microchip. That's commonly used in the 80s stuff, 70s, 80s. But as it gets through the decades, as time goes on, technology, they start using smaller and smaller, and it looks more like this. I'm actually surprised to see this. in this keyboard, because I wasn't expecting to see something like that. This is for the liquid crystal display, and it has got like a microprocessor. It's got all the connectors that goes right the way around it, in contrast to the microchip, which is, or silicon chip, which has only got them on the length edges. This has got it all around it. This is more like Modgen. So if this was a Modgen, this would be a lot smaller and be more of them in it. Right. So these are much more common in the Modgen stuff. But it just shows you that they did have that. For the masses anyway, for us to know, and the technology that we buy, that this was around back then. And there's no telling what's out there, but from what I recall buying and seeing in the 80s, this is what it was like. And if you go by the narrative, these things weren't around so much. There wasn't so much like computing processing as there is today back then, if you go by the narrative, the mainstream narrative. But anyway, that would be much more common. All this would be eliminated, and it'd be more of that, and the boards would be thinner and smaller like that as well, in a Modgen thing. But this is more exciting than the 80s stuff, because there's more to see. All the different stuff, different colours, all the components makes it more exciting. There's a lot more in here than I thought. A lot more craftsmanship, a lot more work. But yeah, I don't really think there's much more to cover really. Well, there is, but on the level that I'm doing it anyway, that's all I'm going to do at the level that I'm covering it. And you could do a video alone just on a microprocessor, depends how deep you want to go, but this is just a general coverage to what I'm going to be putting out and sharing with you. To satisfy my knowledge at the moment about this. For now anyway, this is all I'm doing. So well, that's about it. Right, so well, there's a lot more bits and pieces of it, and there was just a lot more in there than I thought, because I suppose recently I've took apart more Modgen things, so there's more microprocessors and things that are tiny, you can't really see very well. But I'd say there's more craftsmanship going into it. The keyboard was quite big in its own right. Yeah, a small keyboard these days probably do, I don't know, 10 times as much as that for half the size and about 100 times dearer. I don't know. But can't really think much. The magnet's a pretty powerful thing. It's quite a strong magnet. I've broken a speaker before on something, on one of my previous videos. I think it was a TV or something. And I showed the inner workings of it. I can't be bothered doing it with that one, and it's the same principle anyway. It's just a paper cone that vibrates here at the frequency that it's been sent to it by the amplifier, the microprocessor, the transistor amp, sorry, the transistors use an input signal from the input, which will be the keys, or it could be, for example, my amplifiers are used in a lot of things, but in this instance it'll be the inputs from the keys. It must set up a small signal with a preset value deterred by this. So when you stroke one of the keys, hit a key on there, the preset value will send a small signal to the motherboard, basically, to be sent to the amplifier. So this signal that's coming in, small signal produced by this, will go in as a weak signal. The semiconductor will open something to do with the different gates. There's your PNP transistors, NPN. Don't expect me to explain that, because I don't even understand it all. This is just my understanding of it. But it's like a switch, so it's difficult to explain. So if you get a weak signal coming in, right, it's switching on and off, that's a frequency. That will cause the semiconductor to open and close the valve, if you like, for a big power going through it. So the big signal will be the big power that goes through the semiconductor when it's opened. So the big power will open and close at the same rate as which the input frequency is. So the input frequency is the input that will open and close, and In doing so, the semiconductor will open and close the output power, which will open and close at the same rate as the input. So the output power will be significantly higher than the input power, hence being an amplifier, amplifies it and needs power in the amplifier. That then will mean you'll have a big signal that will resemble the input signal. In a nutshell, anyway, there's a lot more to it than that, I can assure you. As I say, I'm not an electronic engineer, but this is my understanding. Don't quote me on it, and just explaining what my understanding of it. But yeah, a wee signal coming in, so when you hit a key on there, a wee signal frequency on and off, a signal wave will cause the semiconductor transistor to open and close the big power going through it. So the big power won't get through the transistor until it's opened. And once it's open, it'll go through it. But when it closes, the big power will stop. But the big power will only open and close in the same rate as the wee power, the wee signal coming in. So the wee signal is determining what the big signal does. The big signal gets its power from the power supply. It's obviously, that's the amplifier, 5 watts I think it is. I don't know the milliwatts or whatever it is for the input. It'll be small anyway. It's quite small resistors on here. The values and that. So it's just like if you have the input signal will close, it will do its wave formation for the frequency. The output signal will have the same pattern of signal as the input, because it's been switched on and off at the same rate as the input signal, and that's what the purpose of a transistor amplifier works, from my understanding of it. There's a lot more to go into it. That's just a very sketch idea, roughly how it works, as far as I'm concerned, from my understanding at the moment, to what I'm explaining to you at the moment on here. The heat generated in the transistor, because it's doing work, it's dealing with the power going in, the high power, the high voltage side, or the high wattage side of it. That's the output. There's a lot of heat generated, so it needs a heat sink, which is on the, well, it's, I'll tell you what, I'll point it. So I'm trying to round it off, but there we go. There's an aluminium heat sink, right? So a lot of heat is generated in there, so I need this to disperse the heat. It's a conductor, a good heat conductor, so it disperses it into the air in the casing. There's probably some vents. I mean, the air will get in there, it's no airtight, but this probably doesn't require vents because it's only like 5 watts, but the heat will be dispersed through there anyway. It just needs to get the heat out of that transistor, because if it stays in there, it'll just burn out and it'll no work. So that's how I identified the amplifier inside this keyboard. That's my bet anyway, just from what I've seen before and my understanding of it. As I say, this is just for entertainment purposes only, don't quote me on it. So, what else? So, the display, the liquid crystal display, I was quite surprised that I saw that in there, because that is like a step closer to what the modern stuff's like nowadays. See, modern things much more sophisticated than that, but that looks more like that. It's got all the lights going right around it. And that, just these wee microprocessors and modern stuff nowadays would eliminate it, take away all the need for all that, because this is bigger. The aim is to get the agenda, the plan. I mean, it's depends on how you look on it. I mean, how you think on it. I mean, if this was all planned all years and it's just following an agenda, but that's something else. But just say for now, for argument's sake, the technology, they invent things that are to make them smaller and smaller to benefit us. That's what the selling point is. But it depends on how you look on it. But how does it really benefit? What's it doing? But again, that's coming off. I'm not going to go into that. It's just kind of keeping it down. More of a sort of mainstream. It's just more showing you what's inside it, and my understanding of it. The technical stuff I'm interested in. I like to know how things work. The political stuff and the agenda, whatever. Why they invent things, what they do, why they make things smaller. It's quite scary what they could do these days with technology. I was on Hillwalk and I saw this thing. It was a deep fake. It showed you someone, doing something that wasn't them, and it was so convincing, but it leads to somewhere else. I mean, this is the technology, and it's quite alarming. But I'll come off of that. So anyway, that's it for this video. I'm going to just tidy all this tidy it all up. There's a lot of bits and pieces, and just going to get disposed of responsibly. Okay, so just see what else I put up on my channel. Hope you found the video interesting. Hope you enjoyed it, and thanks for watching. Okay, right, I'll see you soon. See you again. See you later. Bye. Bye.